All right, so for FRQ number one, part A asks us to calculate the total time from launch until the projectile hits the ground at point C right here. So what I'm going to do is first just draw out the initial launch. So this is VI right here, and then they give us the condition that VI is 50 meters per second. Angle right here. And then this is VIY. We know that VIY is going to be VI sine theta, which is going to be, they say that for sine theta, it's going to be 0.6, so use that. So 50 meters per second, 0.06, it's going to be 30 meters per second. That's your VIY. Your VIX is going to be VI cosine theta. And then they said that for cosine theta, you should use 0.8. Zoom in a little bit. There you go. So 50 meters per second, 0.8. It's going to be 40 meters per second. That's your VIY. So to find the time, I'm going to use a displacement. So delta y equals VIYT plus 1/2 AYT squared. So the displacement, so from the launch and all the way to point C, it displaces negative 35 meters because it drops down to negative 35 meters. Plug in your VIY, so 30 meters per second. T plus 1/2. Your AY is just your force of gravity, and then your AY is just gravity, so it's gonna be 10 meters per second squared. Negative, and then T squared. So what I did was I moved the 35 over. Like put it into this format, so I can use quadratic. And once using quadratic, we find out that T is equal to 7 seconds. There you go. That's part A. Part B. Part B asks us to calculate the horizontal distance r that the projectile travels before it hits the ground. So it's asking for delta x. Delta x is going to depend on VIX t plus 1/2 AXT squared. We know that AX is 0 because no horizontal acceleration. So we just cross this out. So delta x is going to be equal to VIX, which is going to be 40 meters per second, times the t we just found from the previous problem, giving us 280 meters. That. Part C asks us to calculate the speed at points A, B, and C. So for A, at this point, the projectile is at its peak. So at peak, there is no Vy because there's no vertical velocity, so only Vx. So since we know that it's only Vx, we know that also that Vx is equal to Vix throughout the flight because there's no horizontal acceleration. So VA is equal to 40 meters per second. V at point A is equal to 40 meters per second. Again, we're only using Vx at the peak because at the peak there's no Vy. So the only thing we need to account for is Vx, and then Vx is the same throughout as Vix of the initial because there's no horizontal acceleration. So point B right here, we know that the course of the projectile as it moves through the air, it's symmetrical. So it's at the same height right here. So using our common sense, it's going to be 50 meters per second. So on like a multiple choice quiz or something, if it asks us for the velocity at B, we know it's speed at B is going to be 50 meters per second. But just to prove it to you, I'm going to use conservation of energy just to show the work. So it's going to be PE initial plus KE initial equals PE final plus KE final. So that's going to be mgh initial plus 1/2 mvi initial equals mgh final plus 1/2 mv. We're trying to find v at b, so vb squared. So h initial is going to be equal to h final at b because they're at the same height right here. So this being cancel out this, because once we minus over, it's going to turn into 0. So leaving us with 1/2 mvi squared equals 1/2 mvb squared. Cancel out the 1/2 m's, they're the same. Cancel out the squares, leaving us with vi equals vb equals 50 meters per second. Again, if you're pressed for time, we just know that since it's a symmetrical flight like this, same point right here, it's going to be the same speed. And then for part C right here, I'm also going to once again use conservation of energy. PE initial plus KE initial plus PE final plus KE final. So it's going to be mgh initial plus 1/2 mvi initial squared equals mgh final plus 1/2 mvc squared. Like that. Move it up. So the initial height is going to be 35, and then okay, so first I'm just going to cancel out all the m's. Like that, leaving us with g, which is going to be -10 meters per second squared. The initial height is 35 meters. It's 35 meters above the ground, plus 1/2 50 meters per second squared. Meters per second, and you square it like that, equals -10 meters per second squared. 0 meters, the final height. C is at the ground, so 0 meters plus 1/2 vc squared. That's what we're trying to find. You simplify all of this, it's going to turn to 1600 equals 1/2 vc squared. 3200 radical of that, it's going to be equal to vc, leaving you with a vc of 56.569 meters per second. Thank you.